Hello everyone. Today we are going to understand how the Timer0 peripheral works in ARM7 using the LPC2148 microcontroller on Keil uVision. First of all, what is a timer? A timer is a hardware peripheral that counts clock pulses automatically. You can think of it like a stopwatch inside the microcontroller. As soon as the timer is enabled, it starts counting based on the peripheral clock, and the count value increases automatically without CPU intervention. Now, what is this peripheral clock? The peripheral clock is a clock signal used by hardware peripherals like timers, UART, ADC, PWM. Now let's understand the Timer0 registers used in this program. This program uses only two Timer0 registers. One is timer control register T0TCR and the address associated with it is given here. The purpose of this register is to start or stop timer 0. If you set it as 1, it enables timer. So when we write 1 into T0TCR, the timer 0 starts counting. Next we have timer counter register, this T0TC, and this is the address associated with it. This stores the current timer count value. This value continuously increases once the timer is enabled. The objective of this program is to start the timer 0, continuously read the timer count, wait until the count reaches 100 and then set a flag. So this behaves like a simple stopwatch threshold detector. At first let me check if this code has any errors. No error, so I'll go ahead with debugging. Before I run this code, let's understand what's happening here. Area is nothing but an assembler directive which defines a section of memory in order to store this particular information. Timer demo is just a name I have given to that section of memory. You can give any name there. Code indicates this section of memory carries instructions and read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. That is, the first label after this assembler directive is a location where execution actually starts. Start, loop, stop, all these are nothing but labels. And end here is nothing but an assembler directive which indicates the end of source file. Here we see EQU. EQU is nothing but an assembler directive which associates a symbolic name like we see here with a fixed memory address. Whenever you see the usage of this particular name anywhere in the code, assembler immediately knows that this is the address to be considered. This particular address is associated with the timer counter register, and this particular address is associated with the timer control register. In the very first step, we are loading the address associated with the timer control register into the register R0 or R0. Let's see that happening. Yes, and at the same time, let me just open this timer. Fine. As you can see here, there are a lot of registers associated with timer, but this is a simple code and we'll be focusing only on these two registers. So now let's see what's happening here. I'm moving a value 1 into register R1 so that I can store this value into the memory pointed by R0 register or R0 register. Why am I doing that? So that I can enable the timer or so that the timer 0 starts counting. Okay, let's see what happens here. R1 is set as 1 and I'm storing this in the location pointed by R0. So if you see here, enable is set as 1 as soon as this particular task was done. Next, load the address associated with the timer counter register into register R2. Next, I'm loading the value which is stored in this particular memory location into register R3. Let me do that. Okay. Next, during this comparison, that is during the subtraction between R3 and 100, the flags are updated. Here we have branch if lower instruction. This will check if R3 is actually less than 100. If R3 is less than 100, then carry will be set as 0. But if R3 is actually equal or greater than 100, then carry will be set as 1. So now because R3 is less than 100, we will branch back to this particular loop. So this continues. You actually don't need this now. I just opened this so that you can see the value getting updated here. See, what happened here is the value crossed 64. So as soon as C becomes 1 here, this loop is broken. You can notice one thing here. We expect the loop to be broken as soon as R3 becomes 64, but the value seen here is 65. Can you guess the reason behind that? The reason is the timer increments asynchronously independent of CPU. Your code only samples the value, that is, every time this instruction, LDR instruction is executed, whatever value is stored in that address is loaded into register R3. After that, you are checking a condition on the sampled values. As soon as the sampled value meets the condition, that is in this particular case of carry being equal to 1, the loop is broken and R4 is set as 1, and we jump to an infinite loop here. That's all about this code.